Hi. So today we will be doing June 22 question paper 4-3, and this is question 1 of this paper. So first part is asking you to state Newton's law of gravitation. So Newton's law of gravitation is basically the idea that the force of gravitation between any two masses in this universe is going to be directly proportional to the product of their masses, and it's going to be inversely proportional to the square of the distance between them. So let's write this thing down. Okay, so in the next part, they're saying use Newton's law of gravitation to show that the gravitational field strength G at a distance r away from a point mass m is given by. Okay, so they have given you the formula and they're basically asking how this formula is derived, right? So you need to remember that if you talk about force, right? One force is Newton's law of gravitation, which is basically the gravitational force, right? And the other force that applies everywhere is your weight, right? So force that is equal to weight that is equal to mg. That is one formula that you know, and the other formula that you know is for gravitational force, and that is the idea that g m and like basically the product of the masses, and then r square, right? So these are the two formulas. So basically you'll equate both formulas, and so it will be like this: on r square. So which means that the small m will cut. So that will leave you with the formula G equal to Gm upon r square, right? So this is how you're gonna derive it. Okay, so this is it for this part. Okay, then let's move on. What are they saying? The Earth has a mass of 5.998 into 10 to the power 24 kg and a radius of 6.37 into 10 to the power 6 meter. Okay, so they have basically given you the mass and radius of Earth. Same goes for the moon. And then they have also given you one really important thing in which they're telling you that their centers are at a distance of 3.84 into 10 to the power 8 meter apart. And then they're saying that you need to show that the gravitational field strength at the surface of the moon due to the mass of the moon is 1.62 into Newton per kg, right? So that's pretty simple. You know that G, which is your gravitational field strength, is equal to Gm upon r square. And you know that G is basically, it's a constant, right? It's constant of gravitation, and that is basically 6.67 into 10 to the power minus 11, right? So you're simply gonna write the formula first to just show them that you're using this formula, right? So this is the formula that we'll be using, and then we're just gonna input the values in, right? So your G is gonna be equal to, so G is a constant, so I'm gonna just put in its value, which is this, minus 11, and then into again the mass of moon, which is 7.35 into 10 to the power 22, and then upon r square. So r square, that will be, r is given as 1.74 into 10 to the power 6, and we'll just simply square this value. So let's just square this value. So when you solve this, you'll get the answer of 1.62, right? So this is how you're gonna do this. Don't forget to write the units, Newton per kg, right? So this is it for this part. And then they're saying, explain why there is a point X on the line between the centers of the Earth and the moon, where the resultant gravitational field strength due to the Earth and the moon is 0. Okay, so let me explain this a little. So they're basically saying, okay, so you know that if you consider a planet it has its own gravitational field strength, G, which is represented by small g, right? And that is equal to gm upon r square, where is the gravitational constant, and you have m, that is the mass of the planet, and r as the radius, if you're talking about gravitational field strength at the surface. If you're talking about above the surface, you'll add the height, right? So the point here is that each planet is going to have its own gravitational force, right? And that is going to be a downward force, right? So what's going to happen is, and if I'm talking about an object that is placed between the earth and the moon, there will be a point where the gravitational field strength of the earth will be equal to that of the moon. Why? Because their magnitude will be the same at this point. And the other thing is that the magnitude is acting in opposite direction. The earth is pulling towards itself and the moon is pulling towards itself, right? So these are the 2 points we're going to write about in this answer, right? So it will be point. Now let's move on to what I think is the last part of this question. Okay, so calculate the distance x of point x from the center of the moon. Okay, so you know that you can keep the gravitational field strength of Earth equal to that of Moon, right? And that is what we're going to do here, right? So we keep the formula of gravitational field strength, that is gm upon r square equal, and then we input the values, right? And I told you that to keep our answer direct, we're going to keep 3.84 into 10 to the power 8 minus x for Earth and x for Moon, right? Now what we're going to do is that when we're solving, we're going to bring the square terms on one side, so we can shift the square onto the other side and make it a square root, right? So I'm going to solve it this way, and I'm going to get the answer of 3.8 into 10 to the power 7 meter. And that was pretty much it for this question. I hope you liked it.